So for as far as assignments or my stat lab or anything else, do you guys have any questions before we get started? No questions?
So you said the hard copy book isn't required, right?
That's true. Yeah, that is true. Yeah, you get that e-text anyways as part of your my math lab registration or whatever.
Okay.
So if you just want that, you can. I mean, I don't really even assign readings necessarily, but I do. My lectures correspond with the book,
Okay.
so it's worth reading. Actually, I mean, it's actually not a. It's a pretty well written book, actually. So, any other questions? Yeah.
Do the new books still come with those sheets that come with all the formulas and stuff on them?
I don't know. Actually, I'm not sure. I don't know if mine did actually.
I know the old book that you guys just switched from.
Yeah, it had a tear out with a ton of the formulas and the tables and stuff. No, it doesn't. For exams, you would probably. You're just thinking for your own use.
Yeah.
If I had to guess, it probably has something. Let's see. Let's open the book and see if it has formulas in it. Maybe. I don't know if it has that actually. Yeah, I still have a copy of the old one though. If you wanted to go make a copy of it, I could let you borrow it. You come by my office or something, I could do that. I have a feeling there would be some formulas somewhere in here. I just don't know. Let's see. Resources, applications, part 1, blah, 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 blah. Sullivan's pathway to making informed decisions. Oh, okay. Appendix. That's his, like, probably Z tables and stuff. Boom, boom, boom. We'll have fun with that stuff later. What the heck is that table crook?
Yeah, the old one came with tear-outs of all those tables and then
Yeah.
I think some of the formulas too.
Yeah, that was nice. Why are all my tables sideways? That's a little obnoxious. We'll figure it out when we get there. I'm not that familiar with this book yet. Learn about lines? No, I don't know. Maybe not. It doesn't look like it does have that. Yeah. But I still have my own copy if you want to come make copies of it. So, I don't require one on the test or anything, you know. But. Okay. Any other questions? No? All good? Ready to go? I have posted, I finished up the lecture slides for this, so if you want them, the blank ones are there. But I'm going to pull up the annotated ones because those were what we were on yesterday. So yesterday, let's figure out, where were we? Yeah. I know that. We talked about general things about statistics, specifically populations and samples. I gave you kind of a lot of definitions and then sort of the big picture statistics, right? So we're kind of playing this game already with that first activity. Anybody been counting trucks? Anybody been counting trucks yet for that first activity? Yeah. I had a few people give me a submission already, and their estimates were very different. So it'd be interesting to see what strategies you guys come up with. But this is a game. That's the game you're going to be playing when you're counting percentage of trucks, right? Because it's not really possible to see all those trucks out there, right? And so you're just going to have to take a sample somehow and calculate a percentage from your sample. That would be a statistic, and ultimately give me a best guess about the population, right? So you get to play that game first week. It's going to be very fun. I'm very interested to see your answers. And then we talked a little bit about the different types of data, and I kind of made some stuff up here and told you to check the definitions of the book. We're going to skip by that. But this is where we're picking up, right? Types of studies? Does that look good? Okay, so typically we split studies into two types. We have observational studies versus experiments. Okay, so if you had to guess, based on the titles, what do you think the difference between an observational study and an experiment probably is? If you had to guess.
When you're observing an experiment you're doing.
Okay, that's a pretty general, I think that's a pretty decent way to generally describe it. Okay. What do you think of when you hear the word experiment? Like, you're like manipulating something, you're testing something, right? Yeah. So in experiments, so I'll draw a little line here. So in experiments, what you're doing is you're going to intentionally introduce treatments or variables to observe their effect or affect. Effect? Their effect. You can effect something, but you have an effect. Effect on a variable or individual. All right, so yeah, so in an experiment, you're intentionally doing something. So you have some theory about how you're going to affect a person or some variable, and you're going to intentionally manipulate things to try to see what happens. Okay? Can you think of some types of experiments that you've heard of, or places you know where people perform experiments? You guys never heard of any experiments ever?
Science labs.
Okay, so like laboratories, sure. In biology or chemistry, okay? If they're testing some sort of environmental factor or some sort of, I don't know, looking for parts of your brain that are affected by different substances or something, okay? They run experiments for that. What else? Anywhere else you've seen experiments?
I work with kids, so we
You experiment on kids?
we don't experiment on them, but like we try different methods. Like
Okay.
teaching.
Yeah, we do it in education.
And that's an experiment.
That is an experiment. Yeah. So experiments, we do it in education. That's true. Yeah. They do a lot in anything else you can think of. You're not like giving them like drugs or anything, right? Okay. So experimenting with. Okay.
Benadryl in their
Benadryl. Yeah. I like that's the first warning on Benadryl too. It's like do not use to sedate children.
Yeah.
What else? Anywhere else? No, can't think of. I think they do it all. They do it in pharmaceuticals, right? That's how drugs make it to market. They have to go through a pretty extensive experimental phase. So if that's experiments, what do you think observational studies are? Yeah. So basically, I would say something like. By the way, I make all these definitions up, so they're never the same twice. But characteristics about individuals are observed with no attempt to influence their outcomes. Individuals. How about individuals? Are observed with no attempt to influence. Whoa. Where'd you go? Okay. So you're gonna observe things about people or machines or animals or plants, but you're not actually gonna introduce anything and try to make a difference in their environment. So what types of things do you think qualify as observational studies?
That's counting the trucks.
Yeah, that's a good example. Things like surveys or polls. Okay. When you're out counting trucks, it's not like you're introducing any variables in the environment that would affect trucks, right?
Well, I mean, it's in the middle of the road, you might.
Maybe, I don't know. Although you probably don't have much control over who's about to run you over, right? But yeah. I mean, I can't even think of a way you could design an experiment to test that, really. You really just have to observe. If you send out things asking people how they feel about something, you're just giving out a survey. You're just observing what's happening. Okay? Which one of these things do you think is easier to do? Observations are easier. Which one of them do you think is more powerful in the results, though? Yeah, experiments are a lot more. They're a lot more. I would just say more powerful, right? You can make more inference or stronger inference from them, whereas observational studies not so much, because there's a lot of things lurking around that you can't control in an observational study. Okay. So let's look at an example. So this says a study of 22,000 men who received vasectomies and 22,000 who had not was conducted by looking at medical records. So this is a common way of observational studies. They look back at medical records, and they were observing in each group how many developed prostate cancer, and they showed that men with vasectomies had an increased rate of prostate cancer of 113 out of those 22,000 versus 70 and 22,000 in the non-group. So would that be an observational study or experimental? This would be an observational study, right? I think, because they didn't like randomly select men to have vasectomies. That'd probably be a little unethical, right? So, I mean, in a lot of cases, you can't actually even perform experimental studies, right? I don't really know how you would even design this. You would run into a lot of tricky ethical issues trying to design an experiment. So sometimes the best we have is observational study. The problem with observational studies, though, is that just because they perform the study, can you necessarily say that vasectomies cause higher rates of prostate cancer? Not really, right? Because you don't have a lot of control over those 22,000 men in both categories. There could be all sorts of variables running around the background that you didn't control for. And so the note here, right, is that in observational studies, shouldn't, sometimes people do, but they shouldn't lead to declaring causation. So causation is a word we'll use a couple times in this class. So what does the word causation mean?
What causes something?
Yeah, it means one causes the other. So in observational studies, you really can't make that distinction because there's just so many things you didn't control for. So you shouldn't declare causation from results. You see a lot of studies like this published in papers, it's like, wine lowers your risk of heart disease. It doesn't mean you should go just start drinking like 5 bottles of wine every night, to like lower your risk of heart disease. But it's a correlation. It's not necessarily a causation, though it could be, right? But something like that you probably could perform an experiment on, right? Anyways, okay, so that's observational. Yeah? So here's an example, another one. So there's a study of 4,500 pregnant women to observe the effect of folic acid, which is some version of vitamin B. Yeah? B12? B6? Any takers? Doesn't matter. It's folic acid. And they were looking at how it affects birth defect rates. So half the women are given folic acid and half are given a placebo. And at the end of the experiment, they found that women who took the supplement had a lower birth defect rate that was 13 in 1,000 versus 23 in 1,000. Observational experiment? Definitely experiment. What would you think if you performed this study? Do you think it looks like folic acid has an effect? It's small, but if it was a well-designed experiment, then you might be willing to say, yeah, it looks like folic acid is effective. Although you may want to repeat the trial with maybe another sample to see if you can reproduce it. But yeah, at least if it was well-designed, okay, if they performed the experiment well. Yeah?
Okay, and I'm just confused by
Yep.
13,000 versus the 23,000.
Mm-hmm.
This was like a real thing we were doing.
Mm-hmm.
Like, what does those numbers mean?
Oh, it just means 13 out of 1,000 had birth defects in the folic acid group, and 23 per thousand in the control group had birth defect rates. So
And there was like way more people.
yeah, it's a ratio. It's just a ratio. So in a group of 45, you can extrapolate up. So what this would be times 4.5 to get you up to 4,500. So you would multiply that by like 4.5 to get how many were in the total group. It's like a reduced fraction.
Oh, okay.
Yeah. So that was like the rate was 13 out of 1,000 versus 23 out of 1,000 in that group. Yeah. But you're right. There was more people than that. Yeah. Okay. But I think I just reduced the fraction or something is what happened. So, yeah. Okay. Any questions about that? No? Okay. And even so, that's a 10 out of 1,000 difference. So that's still a 1% difference. So, that could be significant, right? Yeah. Okay. All right. So terminology that we use in experiments, actually in any studies really, they really shouldn't say experiments. They should probably just say studies in general, because even in observational studies we're interested in talking about these things. The explanatory variable, that's the variable which is believed to have some effect, whatever. I'm just going to give up. I think it's effect on the response variable, which I haven't actually defined, but okay. So it's the variable you think that if you could change it, maybe you can change people's responses. Okay. The response variable is actually the variable which is believed to be affected. I'm pretty sure that is effect. I changed my mind. Doesn't really matter. Okay, so if you were looking at, say, the if you were talking about, what kind of experiment would we talk about earlier? If you're talking about experiments with like education, right? So the explanatory variable might be, say, your education method that you're going to change, right? The way you deliver your content. And the response variable might be, say, literacy rates, right? Maybe that's what you're interested in seeing. Can you increase the literacy among kindergartners or first graders or something? Okay. And so you think the educational method might change that, and you're going to observe their literacy rates to see if it worked or not, right? Okay, that's the response. And the individuals, I think we all know what individuals probably are. It's pretty self-explanatory. These are just the, these are just the individuals. I don't know. They don't have to be people. That's the thing I'm trying to, things? I don't know. Things which are observed. I don't really know how to say that, but if someone has their book, I'm sure it has a way better definition of individuals. It's like the things that you're taking data about, right? So it could be people, but it doesn't have to be, right? If you're doing your activity 1, your individuals are not people, they're cars, right? They're vehicles, right? Okay. All right. So far, so good? All right. So the advantages of experiments is that they control for things that observational variables can't. So we have something that we call lurking variables. So what do you think a lurking variable probably is in terms of an experiment or a study?
Variable you don't know about.
Could be a variable you don't know about, yeah. And what would be wrong with that variable?
That could have an adverse effect on the data you're taking.
Yeah, so it's like some variable that's lurking in the background that you either don't know about or you can't control that could actually affect the response. So I'll say it's a variable other than the treatment or other than the explanatory variable. So it's some other variable which may affect the response. Okay. Right. So it's something out there that maybe you don't think about or maybe you don't take into account, which is actually playing a part in how your individuals respond, but you didn't think about it or you didn't take it into account. Right?
Can you give an example?
I can. So, maybe you guys come up with an example. So let's think about if you're talking about improving literacy rates in first graders, okay? and you're going to change the content delivery method that you give to them. Well, what are some lurking variables that are floating around that could affect a child's literacy rate that are not the way you're delivering your content?
The home life.
Yeah, so environmental aspects like their home life, right? Do they have a parent at home when they come to school or when they get off school, right? Something like that. Other factors about home life that could affect their literacy rates, right? What else could be affecting that? What's that?
Learning disabilities.
Yeah, so if they have some sort of cognitive disability that could be affecting that, that's very possible, right? What else?
Distraction from that, maybe?
Yeah, so it could be things unrelated to how you're delivering content that occur in the classroom itself, right? So maybe with one group of kids, you just have like Johnny and he's a brat, and then in the other group of kids, not so much or something, right? There's things like that. Anything else you can think of? There's probably 100. I'm hearing a lot from that side of the room.
Friends.
Friends?
Yeah, if your friends in the class.
That's true. Yeah. Could be like the groups, like the grouping, right? Mhm. Sure. Anything else from this side of the class? No? Yeah. So those are all examples of lurking variables. Now the nice thing, though, is that when you do an experiment, you can control for those types of things. So if you know that you have students from a wide variety of, like, say, socioeconomic backgrounds, you could, say, split them into two groups and make sure that you're giving some students from all backgrounds each treatment, right? You can got to control for that ahead of time. Yeah, so that's the nice thing about experiments. Whereas if you're just looking back at observational data, you don't have that control. Okay. Then confounding variables is it's two. Actually, it could be more than two. So I'll say two variables or more, which mask the effect of one or the other. One or the other. That's not supposed to say of. It's supposed to say or. Okay. Okay. So I saw an example of this. They were looking at interventions for middle school students. I think they were sixth graders or something, and they had some combination of treatments like one-on-one tutoring and group study sessions, or like nothing, and then they did all this work. They spent all this money, all this time, and at the end of the year, they didn't actually see any improvements in the students' scores or whatever. But then they noticed that if you split the students by gender, that the boys weren't affected by the interventions, but the girls actually had improved scores with the interventions. But when you didn't take into account the gender, it looked like the treatment was ineffective. So the gender and the treatment were confounding each other, if that makes sense. So the two variables that are masking the effect of one or the other. I don't know if that makes sense.
It makes sense.
No, some people say it doesn't. Some people say it does not make sense. So you can take into account confounding variables by splitting your things ahead of time. So let's say, for example, you have first graders, and some of them have, say, some sort of learning disabilities or cognitive disabilities or something, right? Well, what if you split your class in half, okay? But what if just by random chance, all of your students with cognitive disabilities end up in this group, right? And everybody in this group, none of them have those disabilities, right? Well, if you are applying your new treatment over to these people and you don't see an effect, does that actually mean that your treatment's not effective on the general population? It's not. It's that those learning disabilities might be confounding the actual treatment, if that makes sense. Okay? I don't know. Right? So it's like, just because your treatment might be effective, it's just that there's other things in the background that are masking it because you haven't taken control of them, sort of. Yeah. Okay? Those are confounding variables. Okay. So, I'll give you another example when we look at this one, too. There's other ways you can have confounding variables. So a study of 4,500 pregnant women. Oh, we already did this one, but I want to ask more about it. So this is the folic acid example. So what's the explanatory variable here that we think? Yeah, so the explanatory variable in this example is going to be the folic acid, right? This is the thing which we think is going to have an effect. Okay? What do you think is the response? Yeah. So, okay. Can you think of any potential lurking variables?
Whether the woman smokes or doesn't eat that stuff.
Sure.
That she should do while she's pregnant. Personal health.
Yeah. So the lurking variables, yeah, it could be health, like lifestyle things.
Yeah.
Sure. What else? Yep, could depend on where they live. Could be considered in health, but we'll write down here. What else? Anything else that could be a lurking variable here? I can think of a few that could affect birth defect that we're not taking into account here.
Maybe their culture. Like
Yeah.
some cultures don't want like medical intervention.
Could be, yeah. Although these ones are given the treatment or not.
Oh, that's
You know what I mean? They don't know if they're taking the treatment or not.
Genetics, maybe?
Yeah, I think so. Things like genetics or family history, right? Yeah. So these are the types of things you may want to consider taking into account before you design your experiment, right? So they don't sneak up on you later. All right. You know, so because I mean, what if the other way that lurking variables could occur is if you introduce too many variables into your experiment. So what if you end up giving everyone folic acid, but you also give all the women sort of like dietary guidelines and nutritional advice, right? Well, at the end of the study, you won't know. It's hard to tell and pick apart whether it was the dietary and nutritional advice or whether it was the folic acid that caused the lower in the birth defects rate if you saw an effect or something. Okay. So, all right. So, types of we usually split our types of observational studies into different categories. And now I'm trying to remember why I even put this slide on here. It's not actually that important, and now I'm even trying to remember what we even call case control. I meant to get rid of this slide. But now I left it on there, so it makes me think I didn't want to get rid of it. I'm going to forget about that slide for a second. Don't worry about that. It's not that important. It's just more vocabulary that you don't need to know. Okay. If there's a problem on your homework, then we'll talk about it when we get there. I'm pretty sure I can skip that.
I think there are homework questions in regards to that.
Really, with cross-sectional and case... Okay, I know what cross-sectional and cohort are. I'm trying to remember what case study is, case control. Because as far as I know, cohort is where you measure groups over a long period. Okay, so like I'm going to take a group of students when they first get to CBC, and I'm going to track them for however many years there are students here, right? So, and I keep measuring them at different intervals along the way. Cross-sectional is kind of like what you guys are doing. It's sort of like a one-time sample. And I honestly don't remember what case control studies are. I guess we're going to have to look it up. Oh, sorry about that. I keep it. So cross-sectionals are most common, but do I still have my e-text open? Hey, good. I do. This is in 1.2. And they talk about it. Lurking variables. Yeah, so cross-sectional is when you take it like at one point in time. Case control is when they look back at existing records. So that's a one-time sample in the present, where case control is like looking back at existing records. There you go. So if you're talking about the activity you guys are working on with the trucks, you guys are going to do it. Most of you, I don't know, maybe you'll come up with another way to do it, but most of you will probably do like a cross-sectional study. Okay, you could come up with other ways to do it that were not cross-sectional, but that's the best way. That's probably how most of you will end up doing it. All right. Which one do you think is the best?
Probably depends on the situation.
Probably. It really probably does. Cross-sectional is probably the weakest, but if you get a good sample, it could be pretty good. Case control is not necessarily a bad idea, particularly in circumstances where you don't have the option. But cohort's probably the best because you can control for some of those variables as you go along. Cohorts are hard, though, because people drop out and it's hard to track people over long periods of time. All right. All right, so when we're going out and we say, okay, I know what I'm trying to do, I know what my question is, and now I got to go out and get a sample to look at, all right? Remember, right, that big picture here. From population, right, we have to take a sample. Okay. The question is, how do you obtain this? Okay, so this could be a question you might be asking yourself if you're sitting here trying to figure out how you're going to sample for vehicles to take into your Activity 1 sample. So what do you think are important things that might need to be considered when you're taking a sample? Not necessarily in that activity, but just in general. What do you think?
How big your sample is?
Yeah, so one thing you probably want to consider is how large of a sample you should take, right? Because if you just sample like one car and it's either a truck or it's not, well then you're going to determine that either 0% or 100% of all vehicles on the road are trucks, right? So it's probably not the best idea. You could do it that way. I wouldn't recommend it, though. Okay. What other things might you need to consider when you're trying to decide how to take a sample?
Like where you take the sample from?
Yeah, so things like location. Maybe why would location be important?
Well, because if you went to, like you use the truck, if you say you go by the mall and you sit there and count cars by the mall, you're going to get a lot more cars. Whereas if you drove to the edge of the city limits and tried to take a sample on a country road or something, you're probably only going to get one or two trucks. So
it does depend. So in a case like that, and that's really what that's really getting at is whether or not your sample is representative of your population, right? And so I agree. So there's lots of things. There's the size. Does it represent your population? And there's some ways that we can help control for that. And one of the most basic things you can do is introduce randomness into your samples. So random has a very different name or a very different meaning in statistics than it does maybe colloquially. So when we say a simple random sample, it's a sample of size little n. So by the way, from now on for the next like 11 weeks, if you see a little n in statistics, it always means sample size. Okay? Pretty much always. So it's a sample of size n such that every group of size n has an equal chance of selection. Okay. So if you can, you would like to be able to pick your samples randomly. One way you could do this, the simplest way to do this, which ends up being really hard sometimes, is the way I could think of it is like drawing names out of a hat. or a lottery or something, right? So you're just mixing things around, and you're just drawing names out of a hat. So everybody has an equal chance of selection. All the groups have equal chance of selection. There's no favoritism in that, right? All right? We do random samples a few different ways as statisticians. Most of the time, we just use computers typically. Okay, but there's other ways to do that without a computer. So this is one way to do this is a table of random digits. So I'm going to show you here what your table of random digits looks like. Let's go back to the textbook, and I think it's back in your tables. It's going to be down here in the appendix. I think in your there we go. In your homework, it gives it to you in the actual homework assignment. You don't have to open up the appendix separately. So this is an example of a table of random numbers, and it's literally just that. It's just a bunch of random numbers that have just been spit out onto a page. Okay, and the way they generate them is with a computer. We have like random number generators. And so what we do is they just spit these numbers on the page. So the way a random number generator works is you have this table of random numbers. And so what you do is you assign everybody a number first, right? So this is kind of how you do it anyways. So the first step is assign everyone or every whatever individual a number. Okay. Then you pick a starting place. You pick a starting row and column, okay? And then you just scroll, left to right and select numbers, which pop up. Okay, so like if I was going to go do this, let me see if I have a blank slide here. I want to get you a blank slide here because I'm going to actually do this. I'll let you keep copying that. All right. So let's say that we're sitting here in class, and I want to take a random sample, and I want to pick 5 of you to take a survey for me or something, right? So if I was going to do that, say pick 5 students. All right. The first thing I would do is I would give every single person a number. So I'd probably just go down the roster and I would just assign everyone a number. So so student 1 would get number 01, 02, 03, all the way up to, how many people are here today? $34 people are here today. Very nice. So I would just assign everybody a number, let's say like 1 to 34. And then what I would do is I would say, okay, I'm going to start on, it doesn't actually matter where you start. I'm going to go to my random number generator, and let's say I'm going to start on row 7, right? So you go to row 7, and I'm just going to start scrolling across and looking for things that work. So I go 2 digits at a time because all of my students have been assigned 2-digit numbers. So I'm starting here. My first number is 59. Well, I don't have a number 59, right? So keep going. I don't have a 76, but here's my first one, right? I have a 15, so 15 is in, right? So I'd say, okay, so student 15, I think I could just go with a pen from here. Yeah. So first I'd say, okay, student 15 is in. And then I'd go back to my column, and I pick up where I left off. So I was at 15. 52, I don't have a 52. Do I have a 12? Yeah, I have 12 students. So all of a sudden, hey, number 12, you're in. And then I'd go back. Whoops. I'd say, so 12 was in. Who else is going to be in? It looks like 33 is going to be in. 6 is going to be in. Dang, got to go a long ways. 33, 6, and looks like maybe 26, right? 33, 06, and 26. And I'll just say start on row 7, right? So that's how you use a column or a table of random digits to pick people. It's kind of tedious, actually. But you could do it that way, right? So that kind of makes sense. Now, why do you suppose randomness is a good practice when you're selecting samples?
You're unbiased on your sample selection.
Yeah, that's exactly it. Because, I might think I could be unbiased, but you never really know what type of biases might creep in when I'm picking people to participate in my survey. Or if you're like trying to find locations to look for trucks, for example, you might have an idea of what would make a really representative sample, but in reality, your ideas might be wrong, right? I mean, we might think, oh, more trucks would be here and less trucks would be there, and this would be really representative, but in reality, we're not very good at that. But if we let randomness pick our locations, then we're more likely to end up in a nice variety of places, okay, without our own sort of biases playing into that, okay? So randomness is a really good practice when you're doing sample selection. We don't usually use tables. Normally, we just use technology. So the main tool that we're going to use in this class, so this is a good time to get started talking about it, is we're going to use StatCrunch for a lot of this stuff. Okay, so I'm going to show you how to do that. All right, so let's say when you're logging into My Math Lab, there's always this nice little StatCrunch tab there. And you can open StatCrunch here. You can actually open StatCrunch directly from your homework, typically, if it gives you data tables. I'll show you how to do that when we get into some more of those applications, like in chapter, I want to say 2 or 3. Okay, so StatCrunch just looks a lot like Excel when you first open it up, right? But it's going to do a lot of the stats things that we really like to do. So the way I would probably do it is maybe I would take your attendance. I wonder if, can you export this? I'm afraid if I do a copy paste, it won't work that well. What do you think? Because of all the pictures, it gets all screwy. Let's see what happens. What do you think is going to happen if I do a copy paste?
You try printing it or pasting it as plain text.
I could do that. I bet if I do it in Excel too, it'll work better.
Yeah.
But it says more. What if I do it as keep source formatting? Oh, it's going to freak out. Excel's going to say, no, dude. Can't handle that crap. Hey, knock it off. Shh, go away. Oh, boy. Broke the computer. Let's try one more time. Let's go straight to Pez. What's it going to do? Is it going to work? Well, that was fun. How did it do that? No, it didn't. Well, that was really annoying. There's an easier way to get your names. We have a secret website that you're not allowed to know about. Actually, it doesn't really matter. It's really not that exciting. But this one comes out better. Hey, now you know my ID, so don't use it. But you don't know my PIN. I guess you could spend some time guessing. What is this, 146? Hey, there we go. This is a much nicer table to copy. Let's do copy, but I actually only want the names, so I'm going to go back to Excel. If I'm doing this in an inefficient way, sorry, you're just going to have to get over it. What the heck? It works. It works, I swear. It so works. I'm so serious. This has never not worked for me. I'm wasting so much time. You probably don't care, huh? Give me pay special. Text? How about text? Not text, huh? Do you want it as HTML? No. How about Unicode? Hey, there we go. That worked. All I really wanted was your names. After all that, all I really wanted was your names because I want to put those in StatCrunch. Okay, so I think we could just do an edit paste here now. Okay, use Control V. Why would it even give you the menu option? I just give up. I give up. How about that? There we go. Hey, it finally worked. Okay. It's like, hey, idiot, use the shortcut. Okay, that was fun. This is what I do all day. Okay. Yeah. So okay. Anyways, hey, there's all your names and stuff, right? So they have these nice tools where you can just go in here and I say, hey, I got data that I'd like to sample from, okay? And I just say, hey, variable 1, that's where all your names are, and I would like a sample size of 5 of you. And I go compute, and I say, hey, congratulations, Emma, Stephen, John, Leslie, and Savannah, you're in. Okay? Congratulations. You made the cut, right? The nice thing about random samples, though, is that every time you redo it, right, you'll get a slightly different sample size. So if I pick another 5 people, I'll get a different set of 5 people. So this time, Griselda, Nida, Trevor, Christian, and Marina, you're in, right? Okay, and so you can just keep regenerating samples. And people can occur in multiple samples, but everyone's going to be a little bit unique. There's some probability you get the same one, but it's very, very low. Okay, in fact, we could figure it out. We will figure that out someday. But anyways, yeah, you get the idea? So this is how I would do it if I was trying to randomly select people. I would just sit in here and say, hey, put it in StatCrunch, waste 20 minutes trying to figure out how to copy paste, and then after all of that, I'd have the right people, okay? Yeah? Okay. Anyway, so that's how we typically do it. And anyways, all right, cool. So that's how technology is. There are a lot of ways that we sometimes we intentionally don't randomly sample, or at least it's not completely random. So sometimes what we'll do is a procedure which we call stratified sampling. So in stratified sampling, first what you want to do is you split your population into groups. And those groups are sometimes called strata. I'm assuming that's like Latin or root. I don't really know. But so you split your population into groups, which are sometimes called strata, based on some characteristic of interest. Okay, and then what you do is you go in and you take a random sample from each strata. Okay. So before you actually assign your samples, you split your population up into some type of group, and then you make sure that you take a random sample from every group, not just randomly scattering it about your population to begin with. What do you think would be the advantage of a stratified sampling, or a good reason to use this in some sort of context?
It could eliminate a variable.
Like what?
Like if you were splitting it into men and women.
Okay. So one thing is that if you think that, say, men and women are going to respond differently, it might make sense to split that ahead of time, right? And view how not only then would you have a random sample throughout your population, but you could also split between men and women because you know you're going to have some of each, right? Okay. What else? Any other reasons you could think it'd be advantageous? Any ideas?
You get 2 different outcomes.
You could end up with 2 different outcomes. Not necessarily, but you could, right? You can have more than 2 strata. I mean, you could split people up into all things. What if, for example, I'm taking a sample from CBC students, right? And maybe one of the things I'm interested in is how different people from different, say, ethnic backgrounds respond to something, right? Okay. Well, why might it be advantageous to stratify by ethnicity first and then sample within each ethnicity, rather than just like scattering your samples all across CBC? Why might that be an advantage?
You get a broad spectrum of ethnic backgrounds.
It guarantees you get a nice representation from each ethnicity. What does it also? Can you think of anything else it does?
Might save time.
Could save time. Could. Yeah, sometimes it could be.
More accurate results overall because you.
Yeah, if you really want to know how different ethnicity, because here's one thing, think about there are some ethnic populations in the college that are not very big, right? Okay, so if you just go out and take a random sample just based on the population makeup of CVC, you'll probably end up with a lot of people who are white and a lot of people who have Latino ethnic background, right? What you might not end up with if you just took a random sample is you might not end up with someone, say, who's African American, because it's a small population at our college. So if you're just randomly assigning samples across a college, there might be small portions of the population that you miss, just because they don't make a very large portion of the overall population. And so stratified overcomes. If you really want to see every single ethnicity in your sample, you need to stratify, because there's a really good chance you're going to miss somebody if you don't, right? The disadvantage, though, is that it can be kind of time consuming, because you have to split all those groups ahead, and then you have to go into every single group. So it can be kind of time consuming, yeah? Make sense?
So advantage is you can see all
Hmm?
outcomes.
Yeah, the advantage is you can see specific groups that you're interested in, specific variables you're interested in. The disadvantage is it could be pretty time consuming. Okay. The other disadvantage too is that it might overrepresent some populations that maybe you don't want overrepresented in your sample. Okay. All right, make sense? Cool. So that's a stratified sample. Where are we going? The other way we sometimes will do things is we'll do. Did I miss one? No, I didn't. Systematic sampling is where you basically you just pick individuals based on a pattern. Okay, so you just scatter your samples out based on some pattern. Can anybody think of a way that this might be done?
Maybe you only want to pick pregnant women, so you go with the pattern.
Oh, you're thinking just like pick them on a certain character. I was thinking something along the lines of like every fifth student. But I guess you could do something like that if you were like just something about them. Like I'm just gonna pick everybody who comes through the doors that's wearing red, or whatever. Or I'm gonna pick everybody who's wearing glasses or something. Okay, some pattern. They use this a lot in spatial stuff. If you use like grids. So if you grid up an area and then you scatter about, you take on all the intersections of the grid or something, you're trying to cover a map or something. The nice thing about it is that it's really easy. The bad thing about it is that it can cause you to miss things. Like if you have a big map and you grid it up and then you just take samples at every point on the grid. Well, what if there's something you're really interested in and you miss like an entire like row of stuff or something because you didn't happen to sample on that grid or something, or maybe there's lots of stuff in one area and your grid misses it. That's the downside. Or if you're talking about like machines, maybe there's some sort of weird kink in your machine that only produces errors in every like 96th item or something, and then you'll miss it. But anyways, it's not a bad way to go. Works really well for maps. So. Anyways, that's another way to do it. I think I'm going to hold off for the rest of that, and then that's where we'll pick up tomorrow. Okay. In the meantime, though, I noticed a lot of you did the orientation assignment, but haven't started the actual homework. I would recommend at least getting it started tonight. You really don't want to fall behind on it, because some of those assignments do have a lot of practice problems in them. Okay. So I'd definitely get started on that tonight, if possible.